All right, so this is just a short video on how to simplify radicals. The first thing that we're going to do is start off with multiplying radicals. I know that the square root of a times the square root of b is the same thing as the square root of a times b. So another example of that would be the square root of 5 times the square root of 2 is the same thing as the square root of 10. That's what that means, okay? So when we simplify square roots, we want to make sure that we do not have any perfect squares underneath our radical. So for this example, I have the square root of 8 times the square root of 12, which is the same thing as the square root of 96. All right? Well, I know that 96 is the square root of 16 times the square root of 6. 16, the square root of 16 is 4, root 6. I know that that is my answer. However, some of you are having a really hard time finding perfect squares within this number. So an easy way around that is using the factor tree method. So let's do prime factorization of 96. Well, I know that it's divisible by 3, so 3 times 32. 3 is a prime number, so I'm done with that. Let's look at 32. 32 is the same thing as 8 times 4. 8 is the same thing as 4 times 2. And 4 is the same thing as 2 times 2. These are all primes. But 4 is not. I have to break that down into a prime factor. So that's the same thing as 2 times 2. So when I am simplifying radicals, since this is the square root, I need to find matching pairs of factors. So pairs of factors. So there is a pair of factors. 2 times, here's another identical pair of factors. 2 times these two factors, the 3 and the 2 are all by themselves. They cannot match. They are not a match. So I'm just going to put them underneath the radical. 2 times 2 is 4. So using the factor tree method, I get 4 root 6. Let's do example 3. When I have a whole number on the outside of a radical, I just multiply whole numbers. 3 times 4 is 12. Square root of 3 times the square root of 7 is the same thing as the square root of 21. And there are no perfect squares underneath that. So that is simplified. I'm going to go down to example number 5. I have 2 times 6. 2 times 6 is 12. And then I'm going to multiply my radicals. 5 times 10 is the same thing as the square root of 50. Well, I don't see any perfect squares in there, so I'm going to have to use the factor method. So I know on the outside I have 12 times. Let's use the factor tree for 50. It's divisible by 5. So 5 times 10. 5 is a prime number, so I'm going to underline it. So I know that I'm all the way done with my primes. I know 10 has the factors of 2 and 5. Both of those are prime. Using the method that we just learned, I'm looking for a pair, a matched set of factors. 5. 2 is still a factor and it has no matched set. It goes underneath the radical. 12 times 5 is 60 root 2. All right? Let's look at example number 7. I have the square root of 24x cubed y squared. So I'm going to use the factor tree method for all of these. So let's do factors of 24. Let's see, that's 8 and 3. Factors of 8, that's 2 times 4. Factors of 4, 2 times 2. Again, I'm going to underline my primes right here. Now I'm going to break up this x cubed. Well, x cubed is the same thing as x times x times x, and y squared is the same thing as y times y. Now remember, I'm just looking for matched sets or matched pairs. So I have 2, which I'm going to bring out front, times x times y I do not have a match for the 3, the 2, or the x. So they're going to go underneath the radical. 3 times 2 is 6, times x is 6x. Simplifying, I have 2xy times the square root of 6x. When I divide radicals, if I have a fraction underneath a radical symbol, I can break that up as the square root of the numerator divided by the square root of the denominator and vice versa. The most important thing is that we do not leave radicals in the denominator. We need to rationalize the denominator. And that means get rid of the radicals inside the denominator. Okay? So let's look at our first example. A hint is when the denominator of the radicand is a perfect square, right there, it's easier to separate them. So I have the square root of 11 over the square root of 49. I know that the square root of 49 is 7. So I have the square root of 11 divided by 7. That is totally simplified. All right? If I look down here at example number 14, I'm going to rewrite this as the square root of 75 over the square root of 16. I know that the square root of 16 is 4. I know that the square root of 75 is the same thing as the square root of 25 times the square root of 3. The square root of 25 is 5. So I have 5 root 3 over 4. That is simplified. When the denominator of the radicand is not a perfect square, right here in example number 16, it would be better to try and simplify the fraction. So for example, I see that 88/11 actually reduces to 8 over 1, or just the square root of 8. And I know that the square root of 8 is the same thing as the square root of 4, perfect square, times the square root of 2. The square root of 4 is 2 root 2. Let's look at example number 21. Now, I'm going to break up my denominator. So in the numerator, I'm going to keep that the same for a second. I have 3 radical 2. And in the denominator, I'm going to say the square root of 9 times the square root of b. I know that the square root of 9 is 3. So now I have 3 times radical 2 over 3 times radical b. Two very interesting things happen. First of all, my 3's cancel out. Secondly, I have a radical in the denominator. I have to get rid of that. The only way to do that is to rationalize the denominator. And we do that by multiplying it by itself, or the same term. Remember, whenever we're simplifying fractions, whatever you do to the denominator, you have to do to the numerator, okay? So I'm multiplying these. So the numerator now becomes 2b, the square root of 2b, and the square root of b times the square root of b is just that, b, okay? All right, let's look at example number 22. The first thing that I would do is try to use all of my rules to simplify fractions. I'm just going to ignore this radical symbol for a second. So I know that 48 and 54 are both divisible by 6. So that's the first thing that I'm going to do. I'm going to divide these two terms by 6. 48 divided by 6 is 8, and 54 divided by 6 is 9. Now I'm going to look at my bases raised to a power, right? So I know that when I have division and the bases are the same, the powers are subtracted. 3 minus 5 is negative 2, or essentially, I'm going to cancel this out, and this becomes x to the second power, because 3 minus 5 is negative 2, and I have to drop it positive. X squared goes down here. 1 minus 2 is a negative 1, so I have to drop it positive. Or they cancel out, this cancels out, and I'm just left with y. So here is my new problem once I've reduced. Now I'm going to simplify this as a numerator and a denominator problem, dividing or separating every single term. So the square root of 8 over the square root of 9 times the square root of x squared times the square root of y. Well, the square root of 8 is the same thing as the square root of 4 times the square root of 2. I know that the square root of 9 is 3, and I know that the square root of x squared is x. Square root of y. All right. So the square root of 4 is 2. So I have 2 times the square root of 2 over 3x, the square root of y. The problem is that I have a radical in the denominator. I need to rationalize it. I do that by multiplying by the same exact term. Whatever I do to the bottom, I have to do to the top. You guys can remember those rules. So I'm going to multiply these two together. So I have 2 times the square root of 2y divided by square root of y times the square root of y is just y divided by 3xy. And that is now simplified. Okay? All right. So that's just a short tutorial on how to simplify radicals. I hope that helps.